Ninja Warriors, welcome to yet another power packed session of 2 weeks challenge, and today we'll be starting a very most awaited chapter, I would say, that is application of derivative. But before I get into more details, before I start any further, do let me know whether I'm perfectly audible and visible so that we can proceed with today's session. Yes, in the chat box, please confirm yes, live started, class started, yes. So I am live. But please confirm that yes ma'am, you're audible, you're visible, everything is fine, and you can go ahead and start today's session. Okay? Alright, clear? Vanakkam, keep joining, keep liking and keep sharing the session so that we can have a maximum interaction in this session. Hi Supriya, how are you? Hi Sumanthi, hi Sanjay, hi Shizuka. Alright. Yes, Supriya has given me the green signal that yes, I am completely audible and visible. So yes, without any further ado, we'll get straight into the very first topic of application of derivative, which is rate measure, right? Although rate measure. So if I talk about application of derivative, so what we need to study is rate measure is one of the topics that we are going to study, right? Second will be increasing, decreasing, another topic. And then third will be, we have maxima and minima, and we'll be discussing mean value theorem MVTs. These are the 4 topics which we'll be touching upon. We'll be solving questions, we'll be studying concepts, okay? Alright. Okay, yes. So these are the topics, okay? Alright. Out of all these things, rate is one of the topics wherein you get like you don't get a lot of questions from the very first topic, but still you might get in your exam. 1 or 2 questions can be seen in your JEE Mains exam. So we'll study this very easy. Rate topic is very easy. So we'll study this, solve 2-3 questions, and then we'll focus on the majority high weightage portion. So you know that from application of derivatives, the high weightage portion is increasing, decreasing, and maxima and minima. So we'll get to that. Okay. All right. Let's start rate measure. Let's study the rate measure. So how does the problem related to rate measure are given to us? Let us understand that first. So there are some type of problem wherein a particular rate is given. Suppose df by dt is given to you, right? Rate of change of one quantity. It may be volume, it may be radius, it may be length, it may be anything. It could be anything. So df by dt is given to you and dg by dt is asked from you. So how to tackle such problem if one rate is given and another rate of change is asked? So what you need to do is you need to find the relation between f and g, right? Find a relation between f and g, an equation between f and g. Once you find this equation between f and g, what you need to do is you need to differentiate that relation, both the sides, and figure out df by dt and dg by dt in the same equation. Put the value of df by dt and get the value of dg by dt. That's how we approach rate measure problem. Shall we do one problem and see that how easy it is sounding? Yes. Okay. Let's understand. This question was asked in JEE Mains 2019. You can clearly see that the question says a 2-meter ladder leans against a vertical wall if the top of, so the question says that we are having a 2-meter ladder. So this length is nothing but 2 meter. Okay, alright. If the top of the ladder begins to slide down the wall at a rate of 25 centimeter per second. So what is happening? Suppose this is your x and this is your y. So the top of ladder begins to slide down the wall 25 centimeter per second. That means this point, if you are able to see, this point B is starting to slide down at the rate of 25 centimeter per second. That means they are giving dy by dt. dy by dt is nothing but 25 centimeter per second. Okay, please be careful in units, for units in such type of problem. And now at which the bottom of the ladder, okay, so now they are asking the rate at which the bottom of the ladder is slides away from the wall. That means they are asking dx by dt. As I already told you that rate measure problems, in majority of the problems, what you will do is, you will see one rate and another rate will be asked from you, and what you are looking for is, now, what they are asking is top of ladder 1 meter above the ground is. When the top of the ladder is 1 meter above the ground, so it is sliding, and dx by dt is asked when your y is equals to 1. That means this length finally is 1. So we need a relation between x and y. First of all, we need a relation between x and y. By Pythagoras theorem, I can say that x square plus y square is equals to 2 square. So now if I differentiate 2x dy by dt plus 2y, sorry, this is dx. 2x dx by dt, 2 by dy by dt is equals to 0, and 2 are gone. So over here, x dx by dt, y dy by dt is equals to 0. Clearly that y, the value of y is given as 1, right? And we don't know the value of x. The moment we put the value of x, yes. So Priya is saying why not negative? Yes. So it is decreasing, so we can write down a negative sign as well. Right? Okay. No issues, no worry. Because see what is happening. Y is decreasing, that is understood, and x is increasing, that is understood. So dx by dt is going to be positive. So now y is equals to 1. So we can figure out the value of x. So x square plus 1 square is equals to 4. So x is coming out as root 3. Now plug in the value. So x dx. So that means root 3 into dx by dt is what? Minus 25. And we have plus y is 1. dy by dt is what we are looking for, is equals to 0. So dy by dt value clearly is 25 root 3. Yes. Option A is absolutely right. So option A is absolutely correct. Yes. Okay, Sanjay, you are saying x is equals to 1. It's 25 by root 3. Let me just check. X is root 3, y is, so, oh sorry, oops. dy by dt is given and dx by dt is asked. So yes, this is not 25, dy by dt, so sorry. Yes, so root 3, then we have dx by dt is, we need to figure out. Then we have minus 25 into 1 d and then it is equals to 0. So your dx by dt comes out to be what? 25 by root 3. Yes. So which answer is correct? 25 by root 3. Option B is absolutely correct. Yes, have a look and let me know. Clear? Yes. Alright, now let's move on to the next problem. Again, a similar type of problem is given to us, right? What they are saying is a spherical balloon is being inflated at the rate of 35 cc per minute. Okay, so that means what they are giving is 35 cubic centimeters, right? 35 cubic units. So this is the volume per minute. That means they are giving dV by dt value of a sphere is 35, right? cc per minute. And for a sphere, what is the volume? Who is going to tell me? 4 by 3 pi r cube. And the moment I differentiated both the sides, it will become dV by dt is equals to 3 will be in front. So it will be 4 pi r square dr by dt. Right? So yes, this is given to us. The rate of increase of surface area is what they are asking if the diameter is 14. Diameter 14, that means radius is equals to 7, and they are asking ds by dt. What is S? Surface area. Surface area of sphere is 4 pi r square. If you differentiate it, it will become 8 pi r dr by dt. So r, so I know r is equals to 7, so it will be 7 8s are 56 pi, but this dr by dt is what I am looking for, right? So dr by dt is what we need to figure out. Okay, all right, clear? So dr by dt, for dr by dt, what we need to do is, we need to just put the value over here. So this is 35, if I'm not wrong, 35 is equals to 4 pi r square is what? 49 and dr by dt. 7 के table से we can cut it out. So 7 5s are 35, 7 7s are 49, 7 4s are 28. So 5 upon 28 pi is equals to dr upon dt. Now you can plug in the value of dr by dt over here to get the final answer. Who is going to tell me the value of final answer? So this is going to be, okay, so 2, so 10. Clearly the answer is nothing but option B, 10. The moment you put 10 will be your answer. Who is going to tell me? Yes, Sanjay, absolutely right, absolutely right. Yes, yes, yes. Clear? This question is clear? Yes. Okay, why should we take in the question, Lavanya, if you have read the question nicely, it is mentioned on the question, the previous question, y is equals to 1. Why are we taking? Because can you see, when the top of the ladder is 1 meter above the ground, it is given. So top of the ladder is 1 meter above the ground, that means the ladder is like this, that y is nothing but 1. It is mentioned in the question, Lavanya. Okay, I hope that it is clear. All right. So now so rate measure have two kinds of problems. So you have seen that first problem is pretty straightforward. The second problem was, you have seen it. In second problem, you have to find another dr by dt and then eventually you have to find ds by dt, right? Like that. Now we have a mean value theorem. So let's understand the Rolle's theorem first. So what is the Rolle's theorem? Realize one thing, that Rolle's theorem is absolutely easy. It's just that people are scared about it. But Rolle's, whatever Rolle's Rolle's is trying to say is very easy. Very, very easy. So understand this. Today I will explain you once and you will be like, this was Rolle's theorem. I was scared like that only, just like that. Okay. Alright, so let's understand what is Rolle's theorem. So Rolle says that if a function is continuous in this interval and differentiable in the open interval. So suppose a to b is given to you and function is continuous as well as differentiable, then, and one more criteria Rolle's want to say is, okay, so this is your a point and this is your b point, and if both the values, that means f of a and f of b, both the values are equal, f of a is equals to f of b, right? If both the values are equal, then we can say that yes, then what we can conclude is that there exists one point, at least one point where we can draw the horizontal tangent. That's all Rolle's want to say. That if the function is continuous and differentiable between these 2 points, and along with that these two values are equal, that is f of a and f of b are equal, okay, then Rolle's is trying to say is you can draw a horizontal tangent at least at one point in between these two values. At least. You can draw 2 as well. I am not saying you cannot draw 2, but at least one you can draw. So this is the situation where you can draw the one horizontal tangent. This is the situation where you can draw the 2 horizontal tangent, and there are multiple situations where you will be able to draw multiple horizontal tangent, but that's not the guarantee, because if it is the case, bare minimum you can draw one horizontal tangent. That's what Rolle's is trying to say. Okay, all right. Now y is equals to fx is a function. Okay, so how do we write it? Continuous, differentiable, f of a and f of b are equal. These three are conditions of Rolle's theorem. Then we are saying that there exists a point between a and b such that the derivative at that point is 0, derivative 0, that means horizontal tangent, and we can say that f dash x is equals to 0 has one root at least in a comma b. Okay, I hope that this is clear. Let's understand with the help of a question. So this was asked in 2020. So what they are saying is For all twice differentiable function, it is given that f of 0 and f of 1 are equal and f dash 0 is also given as 0. Right? So that means in 0 to 1, we can apply Rolle's theorem. So in 0 to 1, you can see f of 0 and f of 1 both are equal. So there is a point in 0 to 1 when your f dash x becomes 0 at least once. At least once, this is your Rolle's theorem. So now we can just give the answer based on the options. So f dash x, yes, so f dash x becomes equal to 0 for at least one value, right? Okay. Now 0 to 1, suppose we take C1, suppose we take a C1, C1 belongs to this category. So f dash C1 is 0 and one more point, my f dash is 0, f dash 0 is also 0. So now I can apply another Rolle's theorem on f dash. How? So can you see f dash C1 is equals to f dash 0? That means I can now apply Rolle's theorem between these 2 points, 0 comma C1. So there exists a point K which belongs to 0 to C1 where your f double dash x becomes 0 at least once. So there exists at least one value between 0 to 1. For that it is 0. So which answer is correct? Clearly for some that means this is at least 1. For some means what? For at least one value f double dash x becomes 0. Okay. I hope that this is clear. So option B is absolutely right in this. So first I applied Rolle's theorem between 0 to 1 on f and I realized that there is a point, suppose C1 which lies between 0 to 1 where my f dash C1 is 0. Now my f dash C1 is 0, f dash 0 is also 0. So now I am applying Rolle's theorem from 0 to C1 where C1 is somewhere between 0 and 1. So 0 to C1 my f double dash x becomes 0 and this C1 is nothing but lying between 0 and 1. So that means f double dash x becomes 0 for at least 0 to 1. Okay, alright. Chalo. Now we have Lagrange's mean value theorem. Now Lagrange's mean value theorem is little bit similar to Rolle's theorem only, just one difference. It is having just only one difference. Okay, so that one difference is again same. Fx should be continuous in closed interval and differentiable in open interval. If this is the case, then we can say that okay, this is your f of a and this is your f of b. So this time f of a and f of b not necessarily to be equal, right? So this time these two are not equal. If my function is differentiable and continuous, then what I can say is that I can draw a tangent between these 2 points in such a way that this tangent becomes parallel to line joining these 2 points A and B. So basically tangent slope will become equal to this slope of AB. That's what Lagrange wanted to say. And similar thing Rolle's was saying that okay, the value is equal. So now again similar thing, that these 2 quantities should be parallel. Can you see again these 2 are horizontal lines? Okay, so now the only difference is the values are not equal. That's why this is not a horizontal line. So these 2 are parallel, right? So again, now how to write mathematically? So basically slope of this tangent at C would be what? F dash C. Can you see this is slope of this tangent F dash C and this is equals to slope of AB. How to write slope of AB? Tell me. y2 minus y1 upon x2 minus x1. What is y2? That is value of this f of b is y2. What is x2? So a comma f of a. So these are the values. Now f of b minus f of a upon b minus a is the slope. These 2 slopes are exactly equal. That's what Lagrange is trying to say. Very easy. The theorem is easy. I agree that the application is a little bit different. It can be a little bit different. Okay. Let's understand how to apply LMVT. So question says a function is continuous and differentiable and it is given f of 1 is 3 and we need to figure out the value of f of 5. So I am going to apply Lagrange's mean value theorem, LMVT, where f of 1 and f of 5. So basically between 1 to 5. Between 1 to 5 I am going to apply. Can I do that? Chalo, let's apply. So between 1 to 5, Lagrange says that f dash c is equals to f of 5 minus f of 1 upon 5 minus 1. So f of 5, who is going to tell me f of 5? I don't know. I need the value of f of 5. F of 1 is 3. So f of 5 minus 3 upon 5 minus 1 is 4. And this is your f dash c, which is greater than or equal to 2. Which is greater than or equal to 2. Yes, Rolle's theorem is a special, yeah, absolutely Arjun, you are absolutely right. Yes, now can you tell me that because f dash c would be greater than or equal to 2, so I have applied that f of 5 value will be 4 to the 8 plus 3, so greater than or equal to 11. So the minimum value of f of 5 is nothing but 11. I hope that this is clear to you. This is clear to you. Yes, 11, yes, right, correct. Now this was a question which was asked in 2024, JEE Main 2024 question. So this question was asked in JEE Main 2024. Okay, so the question says that let G is going from R to R be a non-constant twice differentiable function such that G dash half is equals to G dash 3 by 2. If a real valued function f is defined as this, then we need to figure out which of the following is correct. Okay, all right, yes, JEE Main 2024. So first of all, the moment we see this, we wish to differentiate this. And we need to understand that at what all points my f dash is becoming 0. My f dash x, where exactly my f dash x becomes 0, that's what I want to check. Based on that, I will be able to talk about my f double dash x. Are you getting my point? Yes, let's do that. So f dash, let's differentiate it. This will be 1 by 2 g dash x. Okay, and we are having half is outside minus of g dash 2 minus x. That's it, because 2 minus x derivative will give me a minus sign. So this is your f dash x. Now we need to make it 0 and see that at what all points my f dash x becomes 0. So f dash x becomes 0 when my g dash x becomes g dash 2 minus x, right? Yes, it is very clear that if x is equals to half, if I put x equals to half, this equality will hold true. So that means at x equals to half, my f dash x will become 0. True or not? Yes, at x equals to half, my f dash x will become 0. Now at x equals to 3 by 2 as well, if you put x equals to 3 by 2, it is going to become 3 by 2. And it is going to become 2 minus 3 by 2, 1 by 2. These two are equal, it is given in the question. So at x equals to 3 by 2 as well, at x equals to 3 by 2 as well, we can say that these two quantities are equal. I hope that this is clear. So at 2 points, my f dash x is become 0. Now there is one more point which many of the students forgot in 2024. What was that point? What was that point? So that point was when your x and 2x become equal. Please apply your brains. When x and 2x minus 1, when x and 2 minus x becomes equal, so 2x is equals to 2, that means x is equals to 1. So the moment you put x equals to 1, so x equals to 1 is also the point when your f dash x becomes 0, right? Okay, so basically, if I talk about my f dash x, if I talk about my f dash x, it is becoming 0 for 3 points, x equals to 1, x equals to half, and x equals to 3 by 2. Do you guys agree? Yes. And my f dash x is what? Continuous and differentiable, right? So for that, can you see f dash x, so at x equals to 1, it is going to be 0, at half and 3 by 2. So my graph will be somewhat like this. This is my f dash x. Now can you see that on f dash x, I can draw two horizontal tangent. That means my f double dash x will become 0 for at least two values. If I talk about between 0 and 3 by 2, right? So f double dash x equals to 0 for two values, it is becoming 0. So for at least two, so option A, clearly option A is absolutely right, right? Yes. Clear? I hope that it is clear. Give me a big thumbs up if it is clear to you. Very good question. I really loved this question in 2024. Why not B? Supriya is saying for exactly 1 x in 0 to 1. Supriya, yes. Supriya, we never talk about exactly 1. If you have seen Rolle's theorem, now we always talk about at least 1. Because, yes, because we know this information. So based on this information, we can talk about it. We don't know there can be more as well, which is not given here, right? There can be more values of x which is not mentioned in this question. It is not at all mentioned anywhere that only this is true and every other thing is false. So if you see that Lagrange's and Rolle's also talk about at least 1. So can you see there exists at least 1, has at least one root in A comma B, because there can be multiple. It may be possible. I hope the point is clear that we are only talking because it can happen that the graph will look like this, right? It can happen that there are 1, 2, 3, 4, 5 roots of f double dash. That's why we talk about at least. Okay. All right. I hope that this is clear. So that's why we are not talking about exactly. And this is so anyway wrong. F dash 3 by 2, f dash half. Both are 0. Can you see? So D is wrong. Everything for no. So this is so automatically wrong. Only this is correct. At least. Okay. Okay. Now let's talk about increasing and decreasing function. Let's talk about the definition of increasing and decreasing function. So clearly the increasing function definition is very easy, pretty easy. It's just that along x-axis, if your values are increasing, so if I talk about x1 and x2, so across x-axis, if you see that my values are increasing, then if value of x is increasing, value of y should also increase. So at x1, if you are having certain value, at x2, you are going to have a higher value, a greater value. If my x2 is greater than x1, so this is what we call an increasing function. For every x1 comma x2 belongs to this point, if x2 is greater than x1, we will make sure that f of x2 is greater than f of x1. This is what we call as an increasing function. If we increase value of x, value of y automatically should be increased. So this is what we call strictly increasing function, right? And now this is strictly increasing. What about increasing? What about increasing? Increasing function is also called as a non-decreasing function, wherein we say that x2 greater than x1 means f of x2 is greater than or equal to x1. That means that, okay, so this is also called as non-decreasing. So can you see sometimes it is increasing and it has become constant and then increasing, but the function never decreases. It stops for a certain point of time. So you can say that it stops over here, but it never decreases, it never go down. So this is what the definition of increasing function, and this is strictly increasing function. I hope that these two things are clear. Okay, all right, yes. Now similarly, decreasing, as we go, as we increase the value of x, your value of y should be decreased. That's what we call as a decreasing function. So if I pick two values, 2 and 4, so f of 2 should be greater and f of 4 should be lesser, then only we call it as a strictly decreasing function. I hope that this is clear. Okay. Alright, I hope that this is clear. And again, it is said to be decreasing function is also called as non-increasing. Non-increasing. So how does the graph of decreasing or non-increasing function look like? It looks like this. So this is decreasing and then decreasing. Can you see? So for certain period of time or certain values of x, it has become constant, it is non-decreasing, but eventually it is decreasing. So basically it is non-increasing. The nature is non-increasing, it is not increasing at all. So this is how we call it as a strictly decreasing or decreasing function, right? So this is just a definition. Please try to understand this. This is nothing but a definition. This is nothing but definition. But this is not the condition. These things will help us in building our concept, in our understanding, but this from these equations we won't be able to solve any question. To solve a question, we have a tool which is first derivative. So first derivative says that for a differentiable function, and this is applicable for a differential function, it is clearly, this is not a definition, this is just a tool that you can use. So if your f dash x is greater than 0, that means your function is definitely strictly increasing. So if my f dash x is greater than 0, that means my function is strictly increasing. That is first point. Second, if my f dash x becomes greater than or equal to 0, then also we can say it as a strictly decreasing, but on that condition that this equal to 0 is not forming an interval. Okay, so if it is greater than 0, we are sorted. We are super duper happy, no controversy, nothing, just greater than 0, strictly increasing, done and dusted. But if you say that f dash x is greater than or equal to 0, then you should be aware, you should make sure that this equal to 0 is not forming an interval, rather it is becoming 0 at a single point. Okay, so yes, provided the points for which f dash x equals to 0 do not form an interval. So from 1 to 2, f dash x is becoming 0, that is not allowed. If it is the case, it is not a strictly increasing function. So for strictly increasing function, f dash x, in case it is becoming 0, it should be at single point. Okay, all right, and same goes with strictly decreasing. If it is less than 0, we are well and good, we don't need to worry about anything. But if f dash x becomes less than or equal to 0, again equality holds only at the single points, provided they are not forming an interval. Okay, all right, this is actually very important. Shall I tell you with the help of a graph? Okay, let me just tell you with the help of a graph. So suppose we have this graph. Can you see this graph? This is continuously, can you see this is increasing. So this is f dash x will be greater than 0. That will be strictly increasing. Second, now if we say that this is the graph, that means, can you see at this point I can draw a horizontal tangent, but at a single point I am able to draw a horizontal tangent. That's why this is also strictly increasing. Now third graph, is this a strictly increasing graph? No, because my f dash x becomes 0, it is becoming horizontal at an interval. So this is not an strictly increasing, but rather it is a increasing function. Got it? The difference between 1, 2 and 3. If it is greater than 0, then though you don't have to worry. You are like, get lost, I don't want to study anything. But if f dash x becomes equal to 0, you will be like, oh, now Now we have to do something. We have to be aware. Okay, so if it is happening at one point, then you say strictly increasing. But if it is happening in some interval, then you will be like, oh, okay. Alright, same goes with decreasing. I will not over explain now. Let's start solving the questions to understand the working better. So this is your question, right? Let's understand the function fx is equals to this increases on which interval. So we need to find the interval of increasing, right? So basically this is 2 log of x minus 2 minus x square plus 4x plus 1 is equal to f of x. Now f dash x is equals to 2 upon x minus 2 minus 2x plus 4. That's it. That's it. Okay. Alright, this is your f dash x. And now you want to check whether my f dash x is greater than 0 in what interval. So it's just that you have to take LCM first, x minus 2. And this is your 2 we can take common, so this will become 1 minus you are having, okay, so this is 2 minus x, right, if I am not wrong, plus times, so 2 minus x and x minus 2 greater than 0. Now multiply it out, if you multiply, so this will become okay, so 2 and 2 minus 4, okay, so this is gonna be okay, so if I take minus sign common, what will it become? Minus 2, okay, upon we have x minus 2 and this will become x minus 2 ka square, so x square minus 4x plus 4 and we have minus 1, okay. So this is your f dash x, minus 2 upon x minus 2 is here and we are having x square minus 4x plus 3, so x minus 1, x minus 3, okay, this is your f dash x. Now we need to check whether my f dash x is positive, when exactly it is positive. So it is 1, it is 2, it is 3. So this is negative, positive, negative, positive. Okay, so clearly that my positive intervals are these two intervals, minus infinity to 1, union 2 to 3. Minus infinity to 1, union 2 to 3. So 2 to 3, I can clearly see that option B, my function is getting satisfied. Okay. Minus infinity to 1 is not applicable because this is not in my domain, right? Because my x will always be greater than 2. So we don't even have to worry about this interval. Only 2 to infinity is my interval. 2 to 3 it is increasing. 3 to infinity it is decreasing. Okay, this is decreasing, this is increasing. Easy peasy. Yes, got it. Clearly, it is absolutely correct. Okay. All right. Yes. All right. So 2 to 3 is absolutely correct. Now we have another question. Are you guys gonna try it out? So question says that we have a function gx and the gx is given in all these terms related to fx. Now, f dash they are saying is an increasing function, then gx is increasing in which interval, right? So, before, yes, wavy curve I have applied, yes, Supriya. So, I just want to, before I get into more details now, I just want to, I want you to know one thing is very important. So, for an increasing function, if I say that my f is an increasing function, f is an increasing function. If I say that my f is an increasing function, my f is an increasing function if I say, right? Yes, if my f is an increasing function, then f of x1 greater than f of x2 implies x1 greater than x2. Right? That means for an increasing function, we can just simply remove the f. Right? So, if f of x1 greater than x2 means x1 greater than x2. x1 greater than x2. If f of x1 is less than x2, then x1 will be less than x2 for an increasing function. if my g is decreasing function, suppose, then g of x1 greater than g of x2, what does that mean? This implies my x1 will be less. Now sign will be changed. So these are the two very important concepts which you must be aware about. So in increasing function, sign does not change while we remove the function, but in decreasing function, sign will get reversed. Do you know about it? Are you even aware about it? Tell me in the chat box. Okay. So yes. Now what they are saying is, which one is my increasing? F dash x is my increasing function, right? This is my increasing function. Okay. I will keep this in mind and I will now differentiate g dash x, because I want to know that gx increasing, that means g dash x should be greater than 0. G increasing means what? That g dash x is greater than 0, right? G increasing means g dash x is greater than 0. Let us quickly find g dash x. Who is going to tell me g dash x? Yes. Okay. So 1 by 4 is there. Then we have f dash. Then we have 2x square minus 1. So 2x square minus 1, and then we need to differentiate this. So 2 2s are 4x. Okay. And then we are going to have a positive sign. Okay. But okay. And then we are having half f dash 1 minus x square. Let's differentiate this. So this is going to be minus 2x. Can you see 2 2 cancel, 1 by 4 cancel. So g dash x is nothing but, if I take x common, it will be f dash 2x square minus 1 and minus f dash 1 minus x square. This is your g dash x. X has been taken common. Okay. So now what do I want? I want my g dash x to be positive so that I can get to this interval, right? And clearly f dash is an increasing function. If f dash is an increasing function, it is given to you. That means for f dash, this is possible, right? For f dash, this is possible. Let me just delete it. So this is the concept for f dash x, okay? So now if g dash x is positive, if we want to make my g dash x positive, so what I'll be doing is x and these two quantities both together should be positive. So for x positive, this quantity should also be positive. That means f dash 2x square minus 1 should be greater than f dash 1 minus x square, right? So that this is also positive. This whole quantity is also positive. So this should be greater than this one, right? And this f dash, since it is increasing function, we can simply go on and remove it. So now what I'll be getting is 2x square minus 1. This will give me 2x square minus 1 greater than 1 minus x square. So you are going to get 3x square minus 2 greater than 0. And if you solve it using method of interval, so minus root 2 by 3 plus root 2 by 3. So plus minus plus. So you are going to get minus infinity to this root 2 by root 3. Okay. So your answer would be root 2 to root 3. Okay. But for x greater than 0, so you will only accept which quantity? So root 2 by 3 to infinity, this quantity. Okay. Yes. So you are looking for this. So you are only looking for the positive value. Can you see your case was x greater than 0? So your final answer would be root 2 by 3 to infinity. So that means this part. Okay. This is wrong, and this. Now we need to check. For now, if my x is negative, then this should be negative. So for x negative, what we need to do is, if x is negative, this also should be negative. That means the sign will be reversed. 3x square minus 2 less than 0, right? So x, basically if I plot this, so it will be minus root 2 by 3 and root 2 by 3, positive, negative, positive. We are only looking for the negative values, by the way, and my correct answer will be this. So minus root 3 to 0 will be the interval. So minus root 2 by 3 to 0 will be the interval of increasing, both the increasing interval. So clearly option B is absolutely right. This we are getting from x greater than 0. This we are getting from x less than 0. Option B is absolutely right. Yes, yes, yes. in the chat box? Clear? All right. Yes. Okay, so let me just explain it to you one more time, so that what we did. So first of all, g dash x we calculated, it was coming like this. This is your g dash x, x can be taken common. So now I want my g dash x to be positive. Why? Because we are looking interval for increasing function. So the two things are in product. If both, so I want my product to be positive, so both should be positive. So x greater than 0, that means this quantity is also should be positive, and f dash being an increasing function, directly just remove f dash from both the sides. So yes, now my g dash x will become positive and my interval is this. This is rejected because I initially told you that x is greater than 0, so this is my final interval. If my x is less than 0, then this quantity should also be less than 0. Both negative will give me g dash x positive, that means increasing function. So now if x is less than 0, my f dash this should be less than f dash this. So f dash remove, sign will be reversed and the interval will be minus 2 by root 3. Minus root of 2 by 3 plus root of 2 by 3. This is my interval, but we are looking for negative values only. So only negative values are selected, and this is the thing over here. So these two quantities clearly will form my increasing function. This is the final interval. Okay. All right. Clear? Yes. Yes, yes, yes. Now we have a question from 2021. JEE Main 2021. Shall we do it? Yes. So this is your fx, and with what we are looking for is interval of increasing, decreasing. Yes, let's do it. So fx is given as this, and we need to figure out my f is increasing where and decreasing where. So it is very obvious that I would like to differentiate it. So 3 4s are 12 sine cube x cos x plus 10 3s are 30 sine square x cos x. That's it. Now sin x cos x we can take out common. So 12 and 30 and 6 also we can take common. 6 sin x cos x will be out. This will become 2 sin square x. Then we have plus 6 5s are 30. So plus 5 sin x. Okay, I forgot this. No? 6 2s are 12 sin x cos x. So plus 2. That's it. Yes, 2s square plus 5 sin x plus 2. So f dash x is becoming what? 6 sin cos 2 sin square plus, okay, so now this can be further split into two things. So over here we are having 2 sin x minus 1 and 2 sin x, sorry, sin x minus 2. Right? This is what we are going to get. Sin x, and do we have a negative thing over here? Sorry, this is plus, hai na? So plus and plus. So this is sin x plus 2. Correct? This is my f dash x. Now what are the critical points? So we need to check where exactly my f dash x is becoming 0. From method of intervals, obviously. So clearly sin x is 0. So interval is given to you. Minus pi by 6 to pi by 2. Let me just plot. So this is minus pi by 6. So at minus, so this is never gonna be 0. This is always positive. Can you see this is always positive? This is going to become 0 at exactly minus pi by 6. That's it. Minus 30 degree. What about sin x cos x? So sin x is gonna be 0 at x equals to 0. And cos x is going to be 0 at x equals to pi by 2. Now let us understand what is happening in between them. So in first quadrant, it is very clear that 6 sin x cos x is positive. 0 to pi by 2, this is positive. But what about this bracket? So this bracket is again positive in this interval, so this is going to be a positive sign. What about this fourth quadrant? So clearly in fourth quadrant, so this is again going to be positive, but sin x going to be negative. This time sin x going to be negative, so I'm going to get this negative sign. So my f dash x is becoming negative in this interval, that means a decreasing function, and 0 to pi by 2 it is increasing. So clearly option A is wrong, C is anyway wrong, B is decreasing, wrong, only D option is absolutely right. So D is absolutely right, D option is absolutely right. Let me just have a look in the chat box. I hope that you are getting it, because I can't see option D in the chat box. Why are you not able to answer it? Before me, you should be like spamming with ma'am D, 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 D. Why I'm not seeing that? Okay, all right, the option is absolutely right. And now let us understand what is monotonic. Monotonic function, that means without breaking, without anything, the function is either keep on increasing, or the function is keep on going decreasing. So I have one question for you. Is 1 upon x plus 2 monotonic or not? Is 1 upon x plus 2 monotonic or not? GT's art is saying, ma'am, I did not get it. Okay, so previous question, let me just explain you one more time for GT's art. Fx is this. Okay, this is your interval. Okay, now f dash x is this. We take 6 common, sin x common, cos x common, we got this. So finally we are getting this expression. I hope that getting this expression is easy. Now we have this interval minus pi by 6 to pi by 2. So I have plotted minus pi by 6 and pi by 2. And now I am looking for all those values at which my expression is becoming 0. Suppose sin x equal to 0. So this is your sin x. Sin x becomes 0 when your x is becoming 0. Right? So x equals to 0 is another point. Cos x, when does it become 0? At odd pi by 2. That means only at this value, right? 2 sin x plus 1, that means x equals to minus half. So this is minus pi by 6. Sin x is equals to minus 2. Okay, so sin x is equals to minus 2 is not possible. So this will not give me anything. In fact, if you carefully observe, this is always gonna be positive. So this is not at all a problem. This is a positive quantity no matter what value you put. Now understand, first quadrant mein sin x positive, cos x positive, and in first quadrant you put any value, sin x is again positive. 2 multiply positive plus 1. So this is also positive. So I'm gonna get a positive in first quadrant. In fourth quadrant, you know that cos x is positive but sin x becomes negative, and in this quadrant whatever value you are going to put, now this will give you positive value only, because before this you are going to get a negative value, but after this you are going to get positive. So overall this is also positive. So minus plus plus will give you negative sign. So this is decreasing interval, this is increasing interval. That's it. Okay. Why decreasing? Why? Because f dash x becomes negative, that means your fx becomes decreasing. Okay. All right. Okay, now what is a monotonic function? The term monotonous means boring. Boring means not changing its behavior at all. Okay, whether it is keep on increasing, or it is keep on decreasing, it keeps on decreasing. Right, this is what we call as a monotonic function. So if I talk about this function log x, so can you see log x is increasing, monotonically increasing function, right? Getting my point? What about this? So y is equals to 1 upon x plus 2. So if I differentiate this dy by dx, what will it become? Minus 1 upon x plus 2 ka whole square. Whole square quantity is always positive. So overall dy by dx will be negative. So by looking at dy by dx negative means what? Dy by dx negative means what? Tell me. Dy by dx negative means decreasing, and decreasing means, and this is looking like it is strictly decreasing, by the way. So you can say that yes ma'am, true, it is monotonic, but if you plot the graph of it, you will realize at x equals to minus 2 there is a gap, because x equals to minus 2 is not in domain. So the graph will look like this. This is a rectangular hyperbola graph. Y is equals to 1 by x is also looks similar. So this is again, you can clearly see it is non-monotonic. What is happening? Why this test is getting failed? What is happening with my test? So over here, can you see that at x equals to minus 2, my dy by dx is non-differentiable. So this test, when we were studying that test, let me just go back to increasing and decreasing f dash x test. Can you see for a differentiable function, this is applicable. For a non-differentiable function, that means there are some points when my function is non-differentiable, then this test or this tool or this funda or this thing is not working for us. We need to keep that in mind. For that, what we can do is we need to manually check at that point. So I can say that, okay, my function is monotonically decreasing before minus 2, and after minus 2 it is again monotonically decreasing, but between it at x equals to minus 2 it is not happening. Okay, alright. So interval wise it is behaving monotonically, but not the overall. Now let's talk about maxima and minima. Let's do it. Let's go. Yes. What is maxima? What is minima? Let's understand. So first of all, so there are actually some steps which we need to follow to figure out maxima and minima. The very first step is finding critical point. Yes, absolutely, it is false. So the very first step is finding critical point. So what is a critical point? Critical points are all those points where f dash x either becomes 0 or it fails to exist. Right? For example, in the previous case, if this is my fx, right? This is my fx, y 1 upon x plus 2. So my dy by dx, can you see, is this? So either it is 0, so we can make it 0, but it is never gonna become 0. You can see it. No 0 is possible over here. But if it is not becoming 0, then we need to keep in mind all those points as well, where my dy by dx fails to exist, because we don't know what will happen at that point. That will be my doubtful points, my critical points. So x equals to minus 2 is critical point. Even though at minus 2 my dy by dx is not becoming 0, but it fails to exist. So that's why. What are critical points now? Who is going to tell me what are critical points? So f dash x either 0 or f dash x fails to exist. Okay, all right. Now, why I am focusing so much on critical points? So critical points are those points which are contenders of your potential maxima and potential minima. Suppose a function is given, right? And they are asking you figure out the points of maxima and minima. And you will be like, you can't just think about, okay, x equals to 1 randomly, x equal to 2 randomly, x equal to 4, minus 1, minus 3.5. Random numbers you can't guess. You can't keep guessing. You need something that, okay, these 4 points are doubtful points, or these 4 points are those points where I need to check. I don't have to worry about any other points. So this f dash x equals to 0 or fails to exist are all those points which are doubtful points. You just need to check on those points. Rest point, you don't have to worry, right? So it is noted that critical points are the interior points of an interval which are contenders for giving maxima and minima. So if you make it 0, you will get the point, and out of those points, some will be maxima, some will be minima, some will not be. That we need to check. How do we check? Let's understand. First of all, let's find out the critical points. Let's do a question related to critical point. So this was asked in JEE Mains 2021. Let's do a question for only critical point. So the range of a for which the function has critical points, okay? For which this function has critical points. So f of x is this. This is sorted. What about this? What is this written? So this is sine square x and this is cot x. Cot x can be written down as cos upon sine. So sine x by cos x by 2, sine x by 2. So can you see sine x by 2, sine x by 2 gone? So this is 2 cos x by 2, sine x by 2. So this is going to be my fx is becoming 4a minus 3. Then we have x plus log of 5. Then we have 2 sin x by 2 cos x by 2 is sin x. And we are having a minus 7. This is my final fx. Now to get critical points, I need to differentiate it. So f dash x will become, this is your constant by the way. This is your 1 and this is your a minus 7. Sin x will become cos x. This is your f dash x and this should be equal to 0. For my f dash x to have, for my fx to have critical points, my f dash x becomes 0, right? So now what we can do is we can calculate the value of cos x. So cos x will be 3 minus 4a upon a minus 7, right? Yes. And I will get critical point if this equality holds true. This becomes equals to 0 or cos x becomes equal to this. That means my cos x should become what? So basically this 3 minus 4a upon a minus 7 should lie between 1 and minus 1 so that my f dash x will become 0. Yes or no? Yes or no? For my f dash x to become 0, cos x is equals to this quantity. So this should lie between minus 1 and 1, and from here we will get the range of a. So they are talking about the range of a only, and yes. So for that what we can do is we can check. So we can check, okay, the moment I put 0, what do I get by the way? 0 I put 3 upon minus 7 which is lying in this range. That means 0 could be your answer. Yes. And 1 we can check. So 1 pay we are getting 3 minus 4. So minus 1 and upon minus 6. Yeah. Yeah. So one way to go about it is to solve it and get the answer. Another way is option elimination. So you can clearly see A and B having 0. And C and D both are not having 0. So let us check whether 0 satisfies this or not. So 3 upon minus 7 definitely lie between minus 1 and 1. That means either A or B is true. Okay, because 0 is not lying over here. Alright, and one more thing we can check. So over here can you see 1? Here 1 is not involved. Here 1 is involved. So we can check for 1. So the moment I put 1 over here, 3 minus 4 will become minus 1. And this is minus 6. Minus 1 upon minus 6. So 1 upon 6 definitely lie between minus 1 and 1. That means we can say that, okay, 1 will be a part of my answer. So option B we can calculate absolutely clear. Or what we can do is we can clearly just make it between, so this should be less than 1 and greater than minus 1. So less than 1 and greater than minus 1. Okay. Alright. So less than -1 and greater than, yeah. So you will get the final answer as this, option B. Correct? Option B. Right, so JEE Main 2021, good question, I would say, very nice question. Okay, all right, yes. So let us move ahead, and yes, so this is it. This is how you solve it, -4/3 to 2. Endpoint pe check you can do. This is it. Okay, all right. Now let's, so this is critical point. Now till now we are only talking about critical points. Okay, all right. Now let's talk about maxima and minima. Finally, let's talk about maxima and minima. So basically the condition for maxima and minima. So this is your maxima. This is local maxima, by the way, and this is your minima. So first observation in both the diagrams, I can clearly see that for local maxima and local minima, first of all, your f dash x basically should be equal to 0, right? So the very first step is f dash x equal to 0 and get the value of all x. Suppose x equals to 1, 2, 3, whatever. Get the critical points. Okay. Second thing, for maxima, it is very clear that initially my function is increasing, then it is decreasing. Suppose this is x equals to c. This is my critical point, x equals to c, right? So I am checking for only critical points. I won't check for each and every point. I am talking about x equals to c. So before x equals to c, my function is increasing and then it is decreasing. That means my f dash x previously was positive and then it became 0. Can you see? Over here my f dash x becomes 0. This is f dash x positive. This is f dash x negative. So what is happening around c? Before c, my derivative is positive. At c, my derivative is 0, and after c, my derivatives become negative. So that means positive to 0 and then to negative. It is happening, then we have a maxima. And over here, in case of minima, can you see at exactly one point, your f dash x becomes 0. Here it is decreasing, here it is increasing. So f dash x is positive, f dash x is negative. Yes? All right. So this is it. This is how you get maxima and minima. Okay. All right. This is one way to go about it. This is one way. This is first derivative test, right? You have another method as well. Similar method but with a little difference, which is second derivatives test. Second derivative test says that, okay, you go by same method. You calculate first f dash x equals to 0, x equals to c1, c2, get all the critical points, and at all the critical points, you check the second derivative, that is f double dash. So suppose this time you are talking about x equals to a, right? So x equals to a is your critical point which is under test. Now you are looking for whether it is maxima and minima. Who is going to tell you? Either first derivative test, the sign changing, or the second derivative test. Second derivative test is pretty easy. You just differentiate that function, put that critical point and figure out the final value at that point. If it is positive, it is maxima. Negative means minima. Positive means, positive means minima, negative means maxima. It is the reverse thing. Positive, minima. Positive, minima. Negative, maxima. The opposite thing happening over here. Okay? All right. Okay, so sometimes, and what you can say is, okay ma'am, acha, I have understood. Let me just repeat what I have understood. Okay, so you are saying that, okay, I have got a question that calculate the point of maxima and minima. Okay, so I saw the question, I differentiated it, equated it equal to 0. Okay, equated it equal to 0 and got the critical points. For critical points, that f dash x equals to 0, I differentiated it twice and put the value f double dash a I calculated and I found it to be 0. And you were saying that positive means minima and negative means maxima, but I got 0, ma'am. Now what to do? If you are getting 0, that means your double derivative test fails over here. Test fails. Question is still there. This test has a problem. Suppose you go to a doctor, his kit fails. That doesn't mean that you are not sick. Suppose you are having a fever, you want to check the temperature with the help of thermometer and thermometer breaks. That doesn't mean that you don't have fever. Right? Thermometer fails. You can still have that disease. Right? But you don't know. It may be or may not be. That means you cannot test. So for that you can refer to first derivative. That's why two tests are there. Okay. So let's understand the whole concept with the help of this question. Maxima and minima, this is your fx. So yes, fx is given f dash x. So f dash x is minus 3x square plus 12. Okay, if I take minus 3 common, x square minus 4. X plus 2, x minus 2 clearly. So x is equals to plus minus 2 are the critical points. So minus 2 and plus 2 are critical points. Now we will do the wavy curve. F dash x. Can you see the moment you put anything after 2, it is going to give you negative sign. Here you are getting to positive sign, here negative sign. That means here your function is decreasing. Minus 2 to 2 your function is increasing and then it is decreasing. So can you see here you are having minima, negative to positive, that means minima, and here you are getting maxima. Right? So x equals to minus 2 is point of local minima and x equals to 2 is point of local maxima. Rate of change of quantities we've already done in the beginning, no? Yes, so this is your first derivative test. We've done the first derivative test. Now, x equals to 2 minus 2. If we don't know that, we just know the critical points. Now, double differentiate. This is double derivative test to know whether you are having maxima, minima. F double dash x. So, differentiate it further. So, minus 3 to the 6 minus 6x. Okay. The moment you put x equals to 2, you will get f double dash 2 is equals to 12 with a negative sign. That means you are going to get local maxima. Negative derivative means local maxima. Negative double derivative local maxima, and f double dash minus 2 is going to be plus 12 local minima. If you use in f dash x, answer will be 0. Obviously, answer will be 0. F dash x may, if I am going to put this, answer will be 0. From here only I have calculated the critical points. Now, critical points are like this. F dash x equals to 0 at this point. That's how we calculate critical point. So, that means roots of f dash x is nothing but critical point. Yes? Alright. So, local minima, local maxima. Okay. Now, let us understand this question. These type of questions are quite popular in JEE Main. if Px be a polynomial of degree 3 that has a local maximum value 8 at x equals to 1 and a local minimum value 4 at x equals to 3. Okay, that means what they are giving is your P dash x is becoming 0 at what all point? Tell me. At x equals to 1 and x equals to 2. So P dash x is equals to 0 as having two roots, x equals to 1 and x equals to 2. And Px is a 3-degree polynomial. If Px is 3-degree polynomial, its derivative will be a 2-degree polynomial. Agree? So now if I have two roots of a 2-degree polynomial, I can just form P dash x. So my P dash x will be what? So a times x minus 1 and x minus 2. Right? A times x minus 1, x minus 2. No, either first derivative test you will do or second derivative test. Both no need to do all the tests. Okay. Alright, so this is your P dash x. And now what we need to do is, we need to integrate this and get P of x. So P of x will be nothing but a, this is x square minus 3x. So this is a times x square minus 3x plus 2, right? Integrate it. So it is going to be x cube by 3 plus 3x, sorry minus, it is minus 3x square by 2 minus 3x square by 2 and we are having, okay, plus 2x plus b, right? This is your px, okay, alright, this is your cubic equation. Now what they are saying is local minimum value of 8 at x equals to 1. That means P of 1 is nothing but 8, that is first thing. Second thing is x equals to 2, P of 2 is equals to 4, P of 2 is equals to 4, right? P of 1 is 8, P of 2 is 4. So just figure out the value of this a and b by using these two quantities. And if a and b is known to you, P of 0 you need to figure out. Basically what you need is the value of b. Value of b is what you need. P of 0 is what? B. So just figure out the value of a. Right, that's how we do it. Yes. Can you see similar? P dash x is this. Integrating this, you will get P of x. Now P of 1 is 8 will give you this equation. P of 2 is 4 will give you this equation. Solve, get lambda and mu. Mu is minus 12. So P of 0, so this is gone. P of 0 is mu, so minus 12 is absolutely right. Yes, yes, yes. Clear? Sanjay asking why A, ma'am? Okay, so why A? Okay. So that's how we do it. Suppose somebody is telling me ki there is one quadratic equation whose roots are 3 and 4. So I cannot write x minus 3, x minus 4 directly. It could be 2x minus 3, x minus 4. If somebody asks me, why do you write x minus 3, x minus 4? It could be twice of, it could be thrice of, it could be 4 times. So I have to consider all the possibilities, right? Leading coefficient can be anything. Why I should assume that my leading coefficient is 1? Nobody has told me. So that's why I keep leading coefficient as some variable and then figure out, okay? Alright, now till now what we were doing is local minimum and local maximum. Local minimum and local maximum means that minimum value is relative to its neighborhood, not the overall thing, right? Suppose I am having this particular equation. Can you see that this in this graph, this is your local minimum, right? This is your local maximum, local maximum, local maximum, local minimum. So local minimum, these are local values. Local minimum. What is global maxima of this function? So this is local maxima but this is global maxima as well. That means overall maximum value standouts to be this, okay? These are the small peaks, okay? So this is again local maxima, because with respect to its neighborhood, it is bigger, it is greater. But if I talk about the overall graph, this value is greater. Okay, I hope that the agenda of global extreme value in an interval is clear. So you can just understand like this. Suppose you are the topper from your school. So you are local maximum. Now if we are going nationally, like the state topper, so that is also relative, again local, relative maximum. And if I talk about the national, pan-India level, so this is also local. And now we talk about global, international, the overall topper of all the, all across the countries, international. Then we call it as a global topper or global extreme. Okay, got it? The concept and the minimum similar way. Let's understand the question with the help of this procedure. Understand this. We are talking about largest value of this. How to calculate? So there is no such no such algorithm or steps or something like that that you need to follow, that okay, do this, do that. You need to apply common sense in this as per the question. Let me just tell you, it is very easy, absolutely easy. Okay, so this is a cubic equation and this is a restricted interval. So first of all, you all know that f dash x we need to calculate, because all the local maximum and local minimum values will be the contender for global maximum. You know that. Local maximum can become global minimum. If I am a state topper, I can be the international topper as well. Right? Okay. So f dash x we need to calculate. 3 to the 6x square minus 6x minus 12. So this will be 6 if I take common, x square minus x minus 2. So 6 times x plus 2, sorry, x minus 2 and x plus 1. Is this your f dash x? Right, so what are your critical points? Tell me. X equals to 2 and x equals to minus 1. And if I talk about the method of interval, what do I get? So this is your minus 1, this is your 2. So this increasing, then decreasing and increasing. So clearly this at minus 1 you are going to get maxima, here you are going to get minima. Your interval is from minus 2 to 4. Now let me just tell you. So minus 2 and then you are having minus 1 and then you are having 2, then you are having 4. This is what we are having maxima. This is what we are having minima. Okay. So for global maximum, what will happen is, so okay, and increasing, decreasing. So this is how your graph will look like. Your graph will look like this. Right. So for maxima, if I talk about the global maxima, now understand this nicely. Understand this nicely. If I talk about global maxima, it could be at x equals to minus 1 or it could be at x equals to 4 as well. That means extreme values will come into the picture if I talk about the global maxima. So either f of minus 1 or f of 4 will be the value of maxima. Right? Maxima if I talk about. So f of minus 1, who is going to tell me? So this is minus 2, minus 3 plus 12 plus 5. Minus 2, minus 3 plus 12 minus 5. Sorry, plus 5. So this is 5. 5 gone, the 12 is the answer. Now f of 4, who is going to tell me the value of f of 4? So 4 4s are 64 into 2, 128. 128 minus 12. Minus 12 4s are, so minus 48, and then we are having plus 5. So plus 5. Plus 5. Yes, you calculate this value and you realize, okay, that means f of 4 could be the, f of 4 pay you are going to get what value? F of 4 pay you are going to get Yes, 49. Yes, you're going to get a 49, right? 49. Out of 49 and out of 12, which one is the bigger value? 49. So that means at x equals to 4, this time you're going to get the largest value. Did you understand that why f of 4? It could be possible. F of minus 1 pe we would have gotten the bigger value. So we need to check. Here we need to check. Okay. I know that you might be feeling, ma'am, how to check, when to check. Now we need to check every time. Every time, how can we check? So let me just tell you, 1 or 2 examples we'll do. You are like, now I know. Yes, G1's art. Difference between local from absolute. Yes, global and absolute are same thing. Very good question. Global maximum and absolute maximum are same thing. So global maximum value is the largest value of the function, whereas local maximum is nothing but this particular type, this type. This is your local maximum. When you get this type now, so this is your local maximum. Locally it is bigger. Sometimes local maximum becomes absolute maximum. Sometimes just like this, at x equals to 4, it was never a local maximum. At x equals to 4, it was not a point of maxima, but still it is a global or absolute maximum. Okay. Alright. Yes. So, yeah. One more question we'll do, then you will understand the question absolutely nicely. Yes. So let's do this question. What they are saying is, the point in the interval 0, pi for which the value, for which the curve, this and these, that means these two curves are farthest apart. These two curves are farthest apart. So we are having basically two curves and the distance between two curves should be maximum. That means if I talk about E, should be equals to half of x minus sin x. This value should be maximum. The distance between these two, right? E, this expression, this E of x should be maximum. I am talking about the global maximum value. I am only concerned about the whole maximum value. I am not concerned about the local and local, right? And modulus is also there, so I am not talking about the, if the negative maximum is there, I will pick negative value. I am not caring about, I am just talking about the largest numerical value irrespective of the sign. Okay, then the distance will be maximum. Okay, so now what we can do is, we can just differentiate this. 1 by x minus sine, 1 by 2. So just differentiate it. 1 by 2 is equals to, if I differentiate this, what do I get? Who is going to tell me? So 1 by 2. This internal function I want to differentiate, minus cos x should be equals to 0 to get the point of minima and maxima I want to get. So cos x is equals to half, interval is given, so cos x becomes half at what all points? At x equals to 60 degree. So x equals to pi by 3 is one of the point where we can get maximum value. But I already told you that for in extreme points also, in extreme points, because here I am going to get maximum minima type thing. Okay, so x equals to pi by 3 is there. So this is your f dash x. So it is going to have x equals to pi by 3. If I put pi by 3, I am going to get what? I am going to get 0, right? If I put value greater than pi by 3, I am going to get positive, because see, cos 90 degree is 0. So half. So that means positive and negative. Okay. This is 0. This is pi. So the graph is increasing and then it is decreasing. So here I am going to get a minimum value. Okay. Minimum value. And at x equals to pi and 0, I can get the extreme values. So basically we need to check for x equals to 0, x equals to pi and x equals to pi by 3. So Ex will be, tell me, the moment I put x equals to 0, what do I get? 0 minus 0, so I am going to get a 0. And the moment I put pi, what do I get? Half pi minus sin pi, so this is pi by 2. The moment I put x equals to pi by 3, what do I get? So this is pi by 6 minus pi by 6 minus sine pi by 6. Sorry, pi by 3, na? Yes, so pi by 3 the moment I put, so pi by 6 minus root 3 by 2. Okay, modulus is there. So now this is the minimum value. I am talking about the farthest value. So this is pi by 2. That means around 1.5, approximately 1.5. What about this? ये क्या हो गया? नहीं चाहिए. Go, clear. Go. Yes. Pi by 6 minus root 3 by 2. Can someone tell me the numerical value of this? So yes, I am talking about maximum. So this is actually root 3 by 2 minus pi by 6. If you compare these two values, pi by 2 will be the maximum. So pi by 2 will be the maximum value. So yes, so the point in the interval for which the curve is this, so D option pi. At x equals to pi, we are going to get that farthest value. Yes, Supriya. So, and also, if you plot the graph as well, no, this is your sin x 0 to pi, and this is your half x. Half x might look like this. So, can you see that this distance will be maximum over here? At x equals to pi, these 2 points will be farthest apart. Okay? It will become 0. So, like this. At x equals to pi, we are going to see the maximum difference between these two curves. Okay. Distance between two curves is the value of basically y's, difference between y. Alright, so now let us have this question wherein we will solve the function fx is this, and we need to figure out whether my function is strictly increasing, decreasing, and none of these. Okay. So this is my function x upon 1 upon mod x. So let us write my function is this in this manner. So this is x upon 1 plus mod x. Sorry, mod I need to remove, right? When my x is positive, this is x upon 1 minus x when my x is negative. Okay. Alright, equality I can apply over here. Now f dash x, when my x is greater than or equals to 0, so this will be 1 upon 1 plus x square, 1 plus x ka derivative is 1, minus x is constant and over here we have a 1. So this is 1 upon 1 plus x ka whole square, which is positive. So strictly increasing, right? Strictly increasing. Similarly, if I find for x greater than 0 f dash x, what will happen? 1 minus x ka square, 1 minus x is as it is, derivative is 1, minus of this time x is as it is, and the derivative of 1 minus x is minus 1. So can you see again this is greater than 0. So it is strictly increasing. It is obviously strictly increasing. Yes. The answer is strictly increasing. Easy peasy question. Yes. Easy peasy question. Okay. All right. So now we'll be jumping on to the last question of the day, which says the maximum value of this function in this interval is what we need to figure out. So let us figure out the maximum value. For that, we need to find what? f dash x. F dash x will be 4 minus x plus x square, the whole square. This will be as it is. I am applying the product rule. Derivative of x is 1 minus x is constant and the derivative of x is minus 1 plus 2x. Okay, so this is x square minus x plus 4 and then we have minus 2x square plus x whole upon 4 minus x plus x square the whole square, and these two are getting cancelled out. So we are having x, okay, so 4 minus x square upon this quantity. Okay, so x equals to plus minus 2 is something, right? X equals to plus minus 2. Now if I plot the wavy curve method minus 2 and 2, what do I get? X equals to plus minus 2. So this is negative, this is positive, this is negative. So we are going to get decreasing and here increasing. So can you see this is minim, this is maximum. We are looking for maximum. So at x equals to 2 I should get maximum, but can you see? No, it's not in my interval. My interval is minus 1 to 1. So minus 1 is here, 1 is here. So between minus 1 to 1, can you see my function is increasing? For an increasing function, maximum value will happen at x equals to 1. So just put x equals to 1, you will get your answer. So 1 upon 4 minus 1, 3. 3 plus 1 upon 4. Maximum value is what? F of 1. The moment you put f of 1, what will you get? Is it plus or what? Oh, 4 plus. Why it's written plus? No. If it is minus, then the moment you put x equals to 1, so f of 1 would be what? X, so 1 upon 1 minus 1 plus 1. 4 minus 1 plus 1. So 1 by 4, that is, this is correct answer if this is the question. Okay. No D. So there is some issue with the question. In the last step, they are saying it is plus. No. We are considering this as question. So f of this is having a maximum value. What about minimum value? So minimum value you will get at x equals to minus 1. So minus 1 you put, you get minimum value. Okay, they are doing something else. Why have they taken this as plus? I don't understand. Okay, alright. So this was the last question from applications of derivative. And now I would like to tell you some very highlights, important features you can say of your Vedantu Learning Center. So Jeet Ki Raah is something which we are coming and bringing in your nearest center, which is you can clearly see in Bhubaneswar, Delhi, Pune and Patna. Your favorite master teachers, Harsh sir, Pulkit sir and Abhishek sir, AKR sir, will be coming to all these locations, and the dates are also given, the address is also given. For registration, you can click on the link which is given in the registration box. That is one thing, right? And you will be given one-on-one counseling session. You'll be meeting some of the amazing students across your city, and this is going to be a very important and very amazing experience if you visit Vedantu Learning Center, because more students are visiting, enjoying and telling us about the experience and all. So this is happening in Pune, and the very important aspect of it is that you are going to get a personalized attention if you enroll for the course, upcoming course, and I'll be telling you about the upcoming course. But before that, let us talk about the nearest center which will be there. Okay, so Punjab, NCR, Rajasthan, Maharashtra, Karnataka, then Tamil Nadu, you can see there are multiple centers. Andhra, you can see Telangana, Orissa, you can see. Then we have Chhattisgarh as well. So many centers we are having. So you can call or you can click on the link which is given in the description box to book the slot, or to understand that how is the process going on, how to reach that center. So they will help you in any way possible. right? Along with that, yes, so there are some features where students are going and acknowledging and understanding that why VLC, Vedantu Learning Center, is becoming amazing. The first one is that the smart clicker for every student in class. So they are attending the classes and they are realizing that then they have this remote and they can just click on the correct answers and they can play the quiz like we used to do in online class. So you are going to get some of the amazing tech based features across offline and offline, both the best combination you're going to get in Vedantu Learning Center. And yes, you're going to get a dedicated academic mentor, and the doubt solving is absolutely amazing and easy process, very smooth process. You can ask your doubt from master teacher, from your academic mentor, and along with that you can ask the doubts online as well, infinite unlimited doubt solving. Yes, right? So what are you waiting for? Just click on the link in the description box. And one more important aspect, we are very much particular about the students' improvement and their hard earned money. So if you feel that I don't see any improvement in my marks, so you can just go to the Vedantu Learning Center and ask for 100% your fees refund. We will give you that if we are not able to fulfill our promises. Okay, all right, but we are very confident, as you can see also, that over 98% Vedantu students saw an increase in their marks. So that's what it is. And along with that, you can see that the course details and the important dates are flashing on your screen. And yes, so you can just clearly see that in these centers, you can see on your screen the dates are like this. But in Tamil Nadu, the dates are a little bit different. So in Tamil Nadu, we have centers in Chennai. Okay, so 4 centers in Chennai, Coimbatore, Trichy, Madurai. These are the courses and target exam which you can see, start date and all, everything. Okay, so yes, and then AP and TS. So you can see then Andhra Pradesh and ASTS, we are having multiple centers. Again, the dates are mentioned over here. You know what to do. Walk in to our Vedantu Learning Center and call now on this number or click on the link in the description box, right, and get and ask for amazing scholarship offers as well. Okay, so now, and also your favorite, I guess your favorite Shimon sir will be coming to your city, right? So this is Vathi Raidu for Tamil Nadu. How many Tamil Nadu people are here? Tell me in the chat box. And he is going to take the bridge workshop and he'll be available in all the dates. You can see that multiple dates he'll be visiting the different centers. So you can just pick your center, nearest center, and see the date and reach there, attend his seminar, meet him, ask doubts. He will give you personalized attention as well. All right. So yes, this is me, Namrata, signing off. I'll see you all super soon in upcoming session.